Chicos y chicas, hola. Nosotros no hablamos español, pero queremos aprender, porque estamos aquí en Argentina, porque queremos hablar con todas las personas aquí, ¿sí? I'm just kidding. This talk is not going to be in Spanish because we really do not speak Spanish. But once upon a time, we did. Are the slides here? Well, while the slides are coming up, I'll talk to you. I learned Spanish when I was in school, but then lost it. So when we came back to Argentina, guys, can we have help on the... Perfect. So when we came back to Argentina, I had a phrase book with me. You guys know what a phrase book is? Like Lonely Planet. Any people here that don't speak Spanish? Raise your hand. Yeah, you guys know what it is, right? That's that book that tells you... Yes, someone's talking to us.
Hello.
Hey.
We have some problem.
Okay, we tried this a few minutes back, so give us 2 minutes, guys. We'll continue this lovely story. I know you want to hear how it ends.
Bueno, y son las cosas que pasan cuando estamos en vivo, cuando las cosas se hacen con esa energía de la NodeConf, y cuando estemos listos, la gente de iluminación, de video, listo. Señores,
Okay.
un fuerte aplauso de nuevo.
So as I was telling you, we landed in Buenos Aires 2 evenings ago. This is the airport, you remember, baggage claim. It takes a while for the bags to come. So I had my phrase book open, chapter on food, how do you order food, transportation, how do you get around, and of course the most important thing, how do you find el baño? And it's not the best way to learn. In the world of education, this is called push learning because the book is pushing knowledge on you by section. It says for transportation, these are all the words and phrases you should know. What I would have preferred seeing when I landed was instead maybe that label that said that is un televisor en la pared, it's a TV on the wall. Maybe that red shirt the gentleman's wearing is una camisa roja. If I could see the world around me labeled in the language I'm trying to learn, it would be much more efficient for me to learn. Research shows that whenever you are given information, when you want it, when you're asking for it, it sticks in your mind. It's easy to remember. So this is how I would have preferred to learn. This is called pull learning because the learner pulls information and is given information when they want. As developers, the big question becomes, how do we make this happen? How do we code this and bring it to the end user so that they can use it on their phone just by holding the phone up, looking at the world around them, or in the browser while scanning photos on the web? How do we see what's in them so that while we're doing what we do anyways, we can learn a new language? You see, the old ways of learning, old ways of coding, rather, they're very heuristics-based. If this, then that. And in this image, you can see that that red shirt might look like a different red shirt. There's so many different types of red shirts. So if you apply if this, then that, heuristics-based logic, it'll be very inefficient for you to code an image detection or an image captioning system like the one shown here. If you want to detect a TV on the wall, there's so many different types of TVs, there's so many different types of walls. It's very challenging to do that with if-then logic. You might have seen in the title, this talk is about deep learning. That's where machine learning comes in. Machine learning allows a computer to learn the way a human mind learns, a brain learns as the mind is developing in the early days. And the basic way it works, there are 2 phases to it. There's training and inference. The training phase is what we go through when we're kids growing up. And what it means is we are given data, and our parents tell us and society tells us, they give us the labels that my mom might have told me that, Anshul, this is a laptop, and that person there is not a laptop. Positive label, a negative label. These are labels I use to do what's called supervised learning. And then there's unsupervised learning, which is pattern recognition. After I've seen enough of these badges you're all wearing, I begin to know that this is the same thing. If we could teach our computers to learn the same way humans learn, it would be very effective. And it would allow you to code systems like the one you saw, which don't need an if-then line of logic for every single thing. The word shown here is deep learning. It's different from machine learning in that it is a subset that uses very deep neural networks. A neural network is inspired by the biology in our brains where we have neurons. It's depicted here where you have an input, imagine the pixels of an image as the input, and an output, which is a classification, like what is this image? And in the middle, you have what are called hidden layers, and a deep neural network is deeper than a normal network because it has many layers. Only 2 shown here, but a deep neural network has many layers. This is a new paradigm in computing. It's called machine learning and deep learning specifically. We are here today to talk about how we can build systems like the one you saw in the beginning with deep learning, using languages you know, using platforms that are user-facing, namely the browser. The talk is structured as follows. We'll start by talking about how machine learning works today, server-side. We'll talk about some headwinds in this, or rather challenges with that approach, speed, cost, etc. Then we'll talk about some advancements with phones and browsers that allow us to do what we used to do on servers on the client side. We'll talk about a typical architecture of client-side machine learning, show you a demo of what you saw running as a Chrome extension on this laptop here, and then we'll talk about the architecture and show you lots of code to go through that. Of course, you're welcome to ask us questions at the end when we meet up afterwards, and we'll end by talking about what this means for you. What are the problems you can solve with client-side machine learning, and how do you decide whether you should structure your architecture to be server-side or client-side? My name is Anshul. I studied computer science, undergraduate and master's at MIT. I have an MBA from Harvard. My background is software development at Google, Microsoft, etc. I've worked at tech startups. I've also been a consultant at McKinsey, founded an education company called Camp K-12. Nikhila and I together founded an education nonprofit called OpenNet.ai that develops open source AI for education.
Hi, my name's Nikhila, and I'm a software engineer at Facebook in San Francisco. And I spent the past year studying machine learning and AI at Harvard, and prior to that, I studied engineering at Cambridge in the UK. So in a typical client-server setup, most of the machine learning is done on the server. So the training phase and the inference phase that Anshul mentioned both happen on the server, and the client will make requests to the server where the model will then return outputs back to the client. Now, there's a couple of challenges associated with this way of doing server-side machine learning, and we're going to look at 3 key challenges. The first is the infrastructure cost. So over the summer, Anshul and I were working on a couple of machine learning projects, and we were using AWS EC2 instances, which I'm sure many of you have also used, and we're using GPUs to train and run some machine learning models. And it was costing us $24 per day to run a GPU instance. And this could be quite a prohibitive cost for many people and for many applications. So that's the first key challenge. The second is a network connectivity. So some applications rely on strong network connections, and if you can't rely on your server to return the response of a machine learning model, then it might severely affect the user experience. The third is the technical expertise required. So setting up a server to run a machine learning model, so installing the right packages and setting up the server correctly can require quite a lot of technical expertise, which can set a high barrier to entry. But there is some good news. And the good news is that end-user devices are becoming increasingly more powerful. So the decrease in cost and the increase in prevalence of GPUs on MacBooks, on increase in the performance of chips on phones means that we can offer, the phones and computers can allow more complex software to be run. So looking at the browser in particular, the introduction of web APIs like WebGL, WebAssembly expose low-level technology to be used to allow hardware-accelerated graphics and computation. And this is great for performance-intensive applications like machine learning, or processor-intensive applications like machine learning, which can really take advantage of the GPU. So this opens up the opportunity for a whole new way of doing machine learning completely on the client. And the way this differs from server-side machine learning is that the training phase, so actually training the model, still happens on the server, but actually running inference moves completely to the client, so that there's no requests being made to the server anymore.
This is actually a photo I took on my last trip to this wonderful place. I really enjoyed Patagonia. It's one of my friends jumping in to the La Laguna de los Tres. This is an example of a photo, and what we want to do is build a system using the approach Nikhila described, which is client-facing, that sees images like this on our website or like on Chrome as we're browsing the web, and automatically captions them, initially in English and then in a language that a user wants to learn. Because what better way to learn a language than to just see the world around you, to bring that language learning to the person. So what we're going to talk about now is how to do this. This in machine learning is a task called image captioning. You've heard about image classification. Image classification is you take an image and you detect the classes of objects in it. These are single words. Does it have a green t-shirt like the gentleman's wearing? Does it have a blue shirt, shoes? Those are classes. Captions are full sentences. And so an image captioning model differs from image classification. It has two big steps. And I hope the light allows you to see what's here. If it doesn't, I'll walk you through it. Two models here. The first model is an image model. It does similar work to what an image classification model does. It could be, for example, a CNN trained on, if you take Google's ImageNet, on 1,000 classes of objects. What we do with the first model is we feed in an image, and we extract not the answer of what classes are in that image, but the level before that, which is called an image feature vector. This is a fixed length representation of an image. It is not the pixel data of the image. This is an n-dimensional array where these values specify features. Features are a very fuzzy topic. If you think about detecting a banana has a curve. A feature could learn to understand the curve in a banana. It could begin to understand the yellowish color, but they can also be more complex than that. They can be combinations of color and shapes. So these are abstract features, but the nice thing about these features is that no matter how big the image is, the encoding of the image vector, will always be in this feature space which has the same dimensions, which allows it to be used as an input to the next model. The next model is a text model. An example is a generative model like LSTM. And you can feed the feature vector into the text model, and you can compose a sentence, a caption, word by word. So this is image captioning. We're going to walk through an example of this as a Chrome extension that we've coded up. So let's switch to Google Chrome. This is Nikhila's Instagram. And you can see that when I'll refresh it for you so you can see how these buttons got there. When I refresh Nikhila's Instagram, I've just hit refresh. These buttons pop up because the extension is running in the background, going through the DOM, finding all images and adding a button to each of them that says analyze. I'm going to scroll down to this image because this image stands out to me. I'm from San Francisco as well. That's the Bay Bridge in San Francisco. I'm going to hit analyze. You can see it says captioning, and what it's doing now is feeding the image data, pixel data, through the first model, and then through the second model, which generates a caption, and then it's translating it. And you can see what pops up here. Can you guys read it? Should I zoom in? I will zoom in and fix that for you, and zoom out again, because the position wasn't in its place. Un puente que abarca el ancho de un río. Is that right? That's right? Okay, cool. And you can see in English pops up a tooltip saying a bridge spanning the width of a river. I can hover over some of the nouns that it recognizes. Un puente is a bridge. Ancho is broad. I don't know about that one, but you get the point. So the goal of this is neither to be perfectly exact on your caption nor in the translation. The goal is that if you can, image captioning doesn't always work. It's hard. In fact, we'll often find, why don't we try another example of this so you get a hang of how image captioning models work. But what I want to convey to you is that this is not about being perfect in your caption. It's about the idea that if you can provide such functionality to your end users, you can still teach them a new language, because even if they see the raw English sentence or whatever sentence in their local language and a translation for an image that they're seeing, they will still learn from that. And image captioning models will get better and better as the size of the data that they're trained on gets better and better. The inference part will get better. So I want someone here to give me their Instagram account ID. We're going to try this on someone else's Instagram account. Raise your hand if you'd like to volunteer. Otherwise, Nikhila will have to pick. Yes, you. What is just tell us the username. Munchie. Can you spell that for me? I can take a guess, but is it like Munchie like that? Juan? C-H. C-H-I-S. S-A-N. Okay. Juan Chisan. Great. Juan Chisan. So let's hope you have PG-13 images. Okay, they're all you're very nice images. So we're going to wait for this page to load, and we're going to refresh it until it loads on this internet connection, and we will see the translate buttons appear. And and I'm going to load it one more time. It's a very nice photo. Is that daughter, sister, friend, your niece? Very nice. Okay, so it seems to be loaded. Let's see if the buttons pop up. And I can tell you what's happening in the back is in the background we have a script running that waits for all images to be loaded. When all images on the page are loaded, shows the button. So if it's not showing the buttons right now, it's because some of the images down here are taking some time. What if I click on this? And if this doesn't work, that's fine. I'll just type in I'll type in my Instagram. It's slightly different than Nikhila's because it already has all the images in the cache. Okay, so Juan, I apologize, man. We will have to show them your Instagram afterwards because maybe the image loading is taking time. Let me go to Bhagi, which is my Instagram. You'll notice it's very different from Nikhila's because it has only nature photos. And if my internet connection's slow, then even mine won't load, even though it's... We're going to skip this second loading part because it seems like the internet is just slow. So what we're going to do now is switch back to the slides, and Nikhila is going to show you what's happening behind this.
Oh, they popped up.
Did it load? The button's loaded.
Yeah.
So let's go back. See, you guys, we were not making this up. This is very slow.
We'll do it at the end. We could do it at the end.
Why don't we come back to this? We have a more impressive one for you at the end as well. So
you can just open it and let it load.
I'll do that. We'll go here and we'll say Instagram.com one. We'll come back to this. Good idea. All right. Go for it.
So I'm going to talk you through the architecture and what's actually happening under the hood of that Chrome extension. So the key library that we're using is called WebDNN, Web Deep Neural Networks. And this library performs two key roles. So the first is to optimize the models so they can run in the browser. And two is to compile them into a format which can be accessed by the web APIs that I mentioned earlier, WebAssembly and WebGPU. So this is the architecture, overall architecture of the entire app, starting from the models on the left all the way to the browser on the far side. I'm going to take you step by step through this map. So the first thing is to convert the models from Python into a format that can be run in the browser. And WebDNN offers a API in Python with one key module called the graph transpiler. And what this does is takes the model in Python and converts it into a graph description, which is saved as a JSON file, and also optimizes the weights which the model needs to run. So looking at some code for this is the only slide that's in Python. So I know this is NodeConf, so I don't want to put too much Python. But this code shows how to take the model, which is defined in Python. So it's called ResNet50. It's an image classification model. And using two of the functions given by WebDNN, this model can be converted and saved into JSON format. And what I want to point out is in this generate descriptor function, you can specify which of the web APIs you want to use. So WebGPU, WebGL, WebAssembly. And this specifies the order in which they're executed. So if WebGPU is not supported, so currently WebGPU is only supported in Safari Technology Preview. If it's not supported, it will then try WebGL, and if that's not supported, WebAssembly, and so on. So the next step is to actually load the model in the browser and run inference. And for this, WebDNN offers a JavaScript API. And the particular module within this that we're going to look at is called the descriptor runner. And this takes in the graph definition, which is in JSON format now. It's been converted from Python. It loads the JSON graph and the optimized parameters, and loads the model into memory in the browser. So at the bottom, you can see the different backends that are possible, WebGPU, WebAssembly, and WebGL. And this model is now loaded in the browser. So how does this work? How do you incorporate WebDNN? You just have to include the WebDNN.js JavaScript file in your HTML page. And we're going to now look at this run models.js, which actually calls the WebDNN API to invoke the model. So taking a closer look at the run models file, there's a couple of key functions that I'm going to go through. The first is actually loading the model into the browser. And as Anshul mentioned, there's two models that are involved in image captioning. The first is an image model, and the second is a text model. So the first section of this code is loading the two models into the function. And then the last line, caption generator, is encapsulating these two models in a class to allow them to be called much more easily. So that's a load models function. The next step is actually running inference. So this means that we're going to pass in an image, and we want the output caption. And that's exactly what this generate caption function does. So the first step is to pass the image through model 1, and this gets the image feature vector, which Anshul was talking about. And then we take the image feature vector, pass it through the caption generation model, and then get the output sentences. So that was the flow for any web application that can use machine learning with WebDNN. But we took it one step further and implemented it as a Chrome extension. And this comes with a couple of other interesting architectural features that I want to mention. So for those of you who haven't built a Chrome extension, there's a couple of interesting things. So first is that there are two different scripts that can be running at the same time. So the first is a content script, and the second is a background script. The background script runs in the browser, so it's running continuously. And the content script for our application gets injected into each tab that is open in the browser. And the content script can make requests or send data to the background script, which can then, so the background script is where the machine learning model is running. The content script can send images to the background script, which then passes that through the machine learning model and sends the result back to the content script. So I'm going to show you how this looks in code. So Chrome has a message passing API, which allows the content script and the background script to communicate. So starting in the content script, so this is the buttons that you were seeing, the analyze buttons. Those are injected by the content script. So when I click on that analyze button, it's going to get the source of the image and send a message to the background script. The background script, there's a listener, which is listening for that message. It takes the image that was sent and calls run, and run passes that image through this captioning model. Once we have some sentences from the model, the background script then sends a message back to the content script, which also has a listener, which receives the captions, and then we can do something with the caption, so we chose to display it back onto the web page.
And what you have seen with this particular extension is just skimming the surface of what you can do with client-side machine learning. We can touch on a few more things. So the problems that can be solved, you saw image captioning. You can build image classifiers, and an example of where that might be useful is if you think about social commerce or e-commerce, where you want to understand what objects are in a photo so that you can link users to where they can buy that thing. So like a handbag for the ladies or whomever. If you see a handbag, you can recognize it and link people to the exact same handbag on Amazon or another site. That could be pretty cool. So that would require image classification, maybe object detection, which detects where in the image that is. You can do image captioning, which was what we did. You can also do operations on text. You can extract text from the DOM, the same way we extracted images, and you can do sentiment classification, which is detect the positivity or negativity, understand emotions, and again, you would need a corresponding data set which you can use to train your model. That model can sit on that can be trained on the server, and then you can bring the model and the weights for the model to your client side, put it in the background.html file if you're making an extension or in your JavaScript, and run models that do sentiment classification. You can also do other things with text. You can do translation. You can do language scoring. Have you guys played with the Google Translate app by any chance? It's all offline. You can be on airplane mode. It allows you to download a data file. So I have, for example, downloaded the Spanish English data file for Google Translate. It allows me to use it to do translations locally. That's an example of a client-side machine learning platform. It's just instead of the browser, it's on my phone. Language scoring is like Grammarly. If any of you use that extension that gives you grammar advice, it's the idea that you can train something on a corpus of correctly written text, and then you can compare new text that you receive to detect the fluency of it, to detect different features of it, compared to the language model that you have trained on. Style transfer is the viral idea that has been going around, so I'm sure you know about it. It's where you take a selfie or a photo or anything, and it converts it to different styles of art based on what it learns from other styles of art. You can do all of these things offline on client side. And the exciting news, and the reason we wanted to structure this talk on this topic, is the list of things on this side will continue to grow as the trends that Nikhila pointed out become more and more prevalent. So as devices like browsers become stronger, as our phones become stronger, as they start to ship with GPUs, this list will continue to grow. Some of the tools you can get started with right now for web, for browser-based client-side ML, deeplearn.js, keras.js, tensorfire.js, convnet.js. Those are 4, and we use WebDNN. That's another one. The last topic we want to discuss is perhaps one that's most relevant to you, which is the question of, now that you have seen an example of client-side ML, how do you decide whether you want to do client-side ML or you want to do server-side ML for your use case? And we did not do this talk because we believe that client-side is always better. We think there are pros and cons of both, and so want to emphasize that. For example, connectivity. You notice that my extension right now was taking a long time to just load the page, the Instagram page. If you need connectivity, that will restrict you to using one or the other option. So that's an example of what might force you to go down one or the other route. So we've highlighted 7 of them here. The first one is functionality. Despite what we said, that browsers are becoming stronger, devices are becoming stronger, there are certain things that have very large model sizes, so it's not in your best interest to package that as a mobile app or package that as a Chrome extension. It's best to leave that on the server. And so for really high functionality, cutting edge things, you might still need to use the server. Browser compatibility, Nikhila mentioned that there's certain things that WebGPU, for example, is only supported, WebGPU, for example, is only supported on one of the versions of Safari, not on the other browsers. And so if you need the same experience across all devices, then you might be better off just leaving that functionality on the server. Connectivity, we've discussed. Cost and speed, there's a trade-off there. If you do things on the server, you will have to pay. So we paid $24 a day for, which was insane. So we stopped that really quickly on Amazon for AWS for a very powerful GPU. You'll see the demo that we made soon with what we made for that. And if you are okay with that budget, then go ahead and put it on the server. Otherwise, you might have to look at the client side. The flip side is sometimes your client models will perform slowly. So you notice even with my captioning, it took some time. Because if you have a more powerful GPU, you can get it done much faster. So that's the reason you might want to put it on the server. The last 2 are around privacy of 2 types. Data privacy, the last one, that means you can guarantee to your end users that their data is not going to be stored on any server by telling them that all the learning that happens, the inference that happens on the client side. So our captioning system, that image from Instagram, your niece, for example, does not go to our servers. It's all being inferred, going through the model on the client side. So that's an advantage. That guarantee might attract more people to use your platform. Source code privacy. So our Chrome extension, you could just look at the code for it and be able to see the architecture of some of the model structure there. And so if you have a model that's very cutting edge, you want to keep private, maybe client side, at least on a browser, is not the best way to go. So those are the trade-offs that you'll have to think about. We want to end now where we started, with the problem that we identified. And we want to show you how far we have come in implementing that vision of arriving at an airport and seeing the world described to you in real time on a mobile device, which is even taking this idea further. And this, again, is called LingoLens. If any of you want to help us take this to the next level after this talk, please come talk to us. But anyways, we will introduce you to LingoLens. That's all. Thank you.